Today, again, we are moving into the topic which is useful for both the static part as well as the dynamic part. So that is what is called the method of moments. Parallel forces in a plane, center of gravity, center of mass, area moment of inertia, and mass moment of inertia. So these are the topics earlier we have used, but what are the concepts of this we have not much discussed. When we are discussing parallel force also, we have discussed about parallel force concepts, but we have not done in detail. So that's why today we are going to concentrate, this there in syllabus for both the civil and mechanical students. These concepts are very important as from the mechanical engineering point of view, civil engineering, as well as the subjects like engineering mechanics, strength of materials, and design, etc. These are the subjects where we are frequently using this type of analysis. So now let us concentrate the subject of this is what we already said. Now let us see what are the learning outcomes we are going to get. The learning outcomes. The learning outcomes you are going to get in method of moments or by using a parallel, that is represent how to represent a method of moments like theorems like Varigna's theorem, parallel force in a plane, because to calculate center of gravity, center of mass or centroid, we need the concept of parallel forces. Then recognize, employ the concept of center of gravity, center of mass, centroid, or area of moment of inertia, mass moment of inertia. These are the two parameters where we are using frequently: center of gravity, center of mass. Extension is area moment of inertia, mass moment of inertia in statics and dynamics respectively. The concept of sum of the forces moment in method of moments, parallel forces, again we are using. Apply these to physical systems. See, as a student, you have to really understand by these concepts and update your knowledge as per the need. These are the outcomes what you are going to get. Now let us start with the first topic, method of moments. It mainly deals with this concept is credit goes to Varigna's theorem. Archimedes has given the concepts like, suppose if you can see here, Archimedes noted that the amount of force applied to the object, the moment of a force is defined as m into r, where f is an applied force, r is the distance from force to a particular point. But what Varigna's theorem says that moment of force about any point is equal to the sum of the moments of component of that force about the same point. Suppose P and Q are the component of R. Once again I am repeating, moment of a force about any point, I am taking O point, is equal to the moment of a force about any point, so let us say resultant force. These two are components. Moment of this force about this point is equal to the moment of component of the forces P and Q about the same point is called the Varigna's theorem. This, if you can prove this, that is what is going to prove Varigna's theorem. Or it can state that the moment at any point of the force acting on a body is equal to the moment of the resultant of the particular point. Suppose n number of forces are acting and the R is the resultant force, with that the body is moving in dynamics. The moment about these forces is equal to the moment about the resultant forces about a particular point. If these two are equal, then the theorem proved. Or algebraic sum of several concurrent forces, or a coplanar concurrent, any force system about any point is equal to the moments of the the resultant about the same point. Okay. Suppose here the moment or a turning effect. That means the force exerts on objects. That is what is the turning effect or a moment. For example, imagine pushing a door open. You push on the door handle and door rotates around a hinge. The hinge or a pivot. See, that is called the turning effect or a moment. Okay. See, this is what the Varigna's theorem concept is came into the existence. Or it is a simple example. Let us say when you are rotating a nut and bolt, that to tighten or to loose that particular. Considering a wrench subjected to forces C. This is the force P and this is the force Q. Okay. P and Q are the two forces applied. And this is what is the point Q maximum, because if this force is passing to this point, if I want to take moment about this point or moment about this point, we need some perpendicular distances. Okay, if I take moment about this point, these two are passing the same point, that's why you cannot get anything. That's why if I can take moment about this point, this force into perpendicular distance, this force into perpendicular, we need these lengths. Okay. We consider two forces P and Q. Force P, evident that the force P, because this is the force where you tighten or loosen. P will be more effective compared to Q. P is more than the Q. The effective force it regards is the tendency to produce rotation of a body about a fixed point is called the moment of force. Moment is always considering the degree of freedom is rotation, not like the translation degrees of freedom like Fx, Fy, Fz. Moment is equal to magnitude of the force into perpendicular distance of the line of action of the force. Okay. Unit is O is called the moment center. This one perpendicular OD. This is perpendicular distance. Then what is Q maximum arm of P. Now unit is because force into distance. Moment is always Newton meter. Again the theorem, the moment resultant of two concurrent forces. These two are concurrent forces. Two concurrent forces with respect to the center in their plane, respect to the center in their plane, is equal to the resultant of the moment about that point. Okay, with respect to same point. See, that is what is called the Varigna's theorem. Or let us say two forces are acting, P and Q, again a concurrent. Similar earlier. These are the corresponding perpendicular distances. With reference to this, Mn1 is a perpendicular distance with reference to this Mn, with reference to this Mn2, respectively d1, d2, d3. The perpendicular distances of the two forces and the resultant force. P and Q are the two forces. P and Q are the two forces. Okay. R is the force. So now what we have to do? Moment about a point O. Moment about a point O of P plus moment about a point O of Q is equal to the moment of the resultant force R about O. So this is how the Varigna's theorem that can be derived. That is what is the proof of Varigna's theorem. But from the gate examination point of view, the concept should be clear. The proofs derivations are not that much in. It is now let us see that is the previous one is a scalar notation. If you want to vector notation, because as for the right hand thumb rule, force and this is the force acting in the axial, let us say in the upward direction, this is the rotation direction. These two are perpendicular. When they are perpendicular, see the cross product R cos of R cross F. This is 90 degrees already. This you resolve Fx and Fy. This is the resultant force F, Fx, Fy. See the moment about this point of the resultant force R cross F, F is equal to moment about xy. Moment about xy. R cross Fx, Fy. If you can expand Rfx, Rfy, here Fx, this one, into the perpendicular distance y, Fxy, Fy, because this is the also can be considered. Now if we can add the proofs can be considered about the point O. See like that you can explain. Only I am explaining the what is the difference between a scalar notation and a vector notation. Now let us take an example, theorem of Ramjee's theorem. The moment of the resultant two concurrent forces with respect to the center in the plane is equal to the algebraic sum of the moments with respect to the same point, not some point. It is the same point, the same. Now let us consider, note down a problem. A prismatic clear of AB of length 1 is hinged at A and supported at B, is hinged at A and supported at B. Neglecting friction, determine the reaction RB produced at B owing to the weight K of the bar, A prismatic clear of AB of length L is hinged at A. This is the hinge joint and supported at B. This is simply rested on the surface. Neglecting friction at any contact point. Determine the reaction RB produced at B owing to the weight P of the bar. Taking moment about a point A, RB into L, moment about this particular point, RB is the reaction, vertical reaction, into L is the perpendicular distance, and because this is upwards, this is a clockwise movement, Q, L by 2 cos alpha, Q into L by about this point, L by 2, here this is also alpha, and this component is L by 2 cos alpha, the perpendicular distance. Q into about this point moment, and this is the counterclockwise. That is clockwise equal to counterclockwise, R into L. From this you can find out the RB. See that is what it is asked. You have to determine the moment about a particular point A, and you get the reaction at B. See, this is what, as per the Ramjee's theorem, we can represent the equation. RB is equal to Q by 2 cos alpha. Okay, RB into L is equal to Q cos alpha into L by 2. Now a bar AB, note down another problem, similar problem. Like that we can solve a number of problems. A bar AB of weight Q of weight Q and length 2L rests on a very small frictionless roller, rests on very small frictionless roller at D and against a smooth vertical wall at A. And against smooth vertical wall at A. Find the angle alpha that the bar must make with the horizontal in equilibrium. Find the angle alpha that the bar must make with the horizontal in equilibrium. Here see, this is the roller joint. This is the roller. If you remove this, this is the vertical support. Because the roller is, this translation is possible, this rotation is possible. Out of 3 degrees of freedom, it is in a plane. This is an unknown vertical reaction. Weight is acting downwards. This is the reaction upwards. And this is the reaction on D. Now you take moment about this point or this point. But if you consider 3 forces, weight, reaction force, and this particular joint. Now out of this you take any reference point, neglect one force. If I can take this point, this force moment you don't get. That's why now unknown is RD if the Q is given. Okay. So now find out this for a Q, this is the perpendicular distance. For reaction force, this is the R, L. Okay. Now RD. For this is the perpendicular, for this it is a perpendicular. If it is alpha, it is also alpha. To keep force parallel to this, now what we have to do is, this RD cos alpha is equal to upward is equal to downward. Or Q also resolve and keep as it is RD. And then resolve upward and downward, resolving vertically. Now let us take moment about A. This moment about this point. This into perpendicular distance. Because this is an unknown, you have to determine. RD can be find out. From this, A cos alpha is equal to this by this. Like that, if you can use the expression RD moment about this is Q into Q downwards, this L cos alpha. QL cos alpha, RD into this L. Okay, that can be Q into this L, Q can be resolved, Q cos alpha and Q sin alpha. Q cos alpha into L is equal to 0. From this you find out the whatever the unknown. Now let us consider if the piston of the engine has a diameter of 101.6 mm. If the piston of the engine has a diameter of 101.6 mm and has a pressure in the cylinder is 0.69 megapascal and the pressure in the cylinder is 0.69 megapascal. Calculate turning moment M. Calculate turning moment M exerted on the crankshaft. Calculate turning moment M exerted on the crankshaft for a particular configuration. Here the force is P. This is 170, this is 380 mm, it is 90 degrees, it is making an alpha, it is S and F, the forces. If a piston is moving up and down, that is what is the motion. Now let us see if you can consider the area of the cylinder is pi by 4 d square Force exerted on the connecting rod. This is the connecting rod. Force exerted due to piston inside the. This force is equal to pressure into area. Okay. This is what is the pressure into area. Area is already we got. Pressure is given 0.69 megapascal. 0.69 10 power 6 Pascal. Pascal is Newton per meter square. Area is in meter square. Meter square will cancel. Force is in newtons. Okay. Now this is what is the connecting rod. Force in the connecting rod, and it has to be resolved with respect to vertical and horizontal. From this, alpha can be obtained. Sin alpha, if it is a rectangle triangle, 90 degrees, opposite side by sin, this sin alpha is equal to adjacent side by this particular length. From this, find out this value. Okay, so that's what we are represented here. 178 by 380. From this, S cos alpha, S cos alpha, S sin alpha. From this, if force, find out S cos alpha is equal to F. F is already got here. Then determine the moment. Okay. Now this S cos alpha into point S cos alpha about this point. This is the length. S cos alpha, S sin alpha. Okay. And this is how we can determine the problem. Now let us note down the last problem in this particular concept. A rigid bar AB is supported in a vertical plane. A rigid bar AB is supported in a vertical plane and carrying a load Q at the free end. Neglecting the weight of the bar. Find the magnitude of tensile force S in the horizontal string CD. Find the magnitude of tensile force S in the horizontal string CD. Let us say by taking moment about A is equal to 0. Because this length is known, weight is acting downward, this is S in the cable. This value is L by 2 and this value is L. That's why L by 2 cos, this is 90 minus alpha. Then L by 2 cos alpha, this is the perpendicular distance. Later we use the sign convention. This S is the perpendicular distance. This is L by 2 cos alpha. This one. You have to. This L by 2, this is L. This is 90 minus alpha. All cos 90 minus alpha. Sin alpha. You have to substitute in the corresponding equation. Then simplify the problem. Find out the S. So this is how we can determine any unknown in the problem by considering the method of moments. That is by using the Ramjee's theorem. See, once again, we can conclude this part of method of moments. The meaning is, if you take moment about any point, of component of forces equal to the resultant of the force about the same point. Or in other words, clockwise and counterclockwise, if you can combine and equate to 0, that's what the moment. It is a pure rotation, it is having 1 degree of freedom. You can determine the 1. This can be used to both the, suppose in dynamics, same rotation equation, m is equal to I alpha. Where in statics, I alpha is 0. Alpha is, let us say 0, uniform motion, there is no acceleration, alpha is 0. So this is how the concept is used. Now let us see the next concept is parallel forces. This is also center of gravity, center of mass, and these are the cases where always we are considering forces are parallel with each other in a parallel force system. Without understanding parallel forcing, even if you want to do the moment of inertia, that is very, very difficult. You will do a lot of mistakes. You have to first get what is the pure concept of parallel forces. Suppose the parallel force means number of forces are acting, the distance between any two forces, this distance is always constant, is not variable. With a variable is not a parallel. In that all forces may be acting in one direction, or some force acting in one direction, some force acting in the other direction. If all the forces acting in one direction, it is a line. If all the forces one direction and the third is another direction, it is unlike parallel force. One is a like parallel forces, another is unlike parallel. Resultant of like parallel forces, add up all these three. Okay, let P and Q are the two like parallel forces, add the two, that is what is R. R is equal to P plus Q. When the body in a translation. Okay, if it is an unlike parallel forces, unlike means like this. Two forces are in one direction, third force in opposite. In that case, suppose let us say an example, R is the direction of the force having greater magnitude, then the resultant is equal to like this. Now let us see the couple. Couple is nothing but 2A and equal and opposite, unlike parallel forces. Unlike, but magnitude is same. Unlike equal parallel force, otherwise. It is called the couple. The rotation effect the couple is measured by its moment. Okay. The positive and negative you can consider sign convention is anti-clockwise or clockwise. Okay. Or vice versa. The choice is yours. But throughout the problem you have to follow the same procedure. You cannot change one part of the problem at counterclockwise, positive, clockwise, negative, and another part clockwise, positive, and counterclockwise, negative. We cannot do like that. Okay. Now let us here also solve. See the parallel forces. This is one and this is another. If we extend this, form a couple. Whereas here horizontal support vertical reaction, hinge support horizontal and vertical reaction. If I take about this point, moment reactions first you have to determine. Once we know the reactions, then we can apply Lorentz theorem. Okay? Or by using some of the forces in vertical direction 0. Vertical is due to two reactions. That's all. RA and RB. So now what we have to do? RA upwards, RB upwards. Take moment about vertical 0. Vertical 0 means RA plus RB is equal to 0. You are taking moment about A, about this point. Then here, if you can see here, this is the vertical reaction, like this. Okay, that is what is RB. By say RA is also hinge, horizontal and vertical reaction. Taking moment about A, why? Because two forces are acting, two unknowns we can eliminate. About if you take about A point, moment about this point is equal to RB. Let us say this is RB. RB into L is equal to RB into L plus P into 1P, P into B is equal to P into A, P cross A. From that find out RB. Once we know the RB, you can find out RB. See, this is now the, here we can see the moment about this point. This is given A and B. Now let us consider a weight W of the locomotive shown in figure. The reactions at the 2 points of support A and B will each be equal to W by 2. Because by symmetry, if you want, you can derive. By symmetry, this is one, this is one, this is one. Okay. Upward force is equal to downward force. Sum of the vertical is equal to 0. RA plus RB is equal to W. That is one equation. Then taking moment about this or this, your choice. I am taking moment about B point, this point. Then you take RB into A plus A to A. Then P into B. Let us say known quantity, W into A, about this point I am taking, moment about. Or moment about this point. This point, P into B, this is the RA into 2A, is the expression. From this find out R. That you can find RA, you can resubstitute, find out the moment about point B. So this is one principle what we are calling as the concept of parallel forces. Now let us see, these are the like parallel forces, but not all are equal magnitude. P's are equal, but Q is not equal. The distance are given. This is a simply supported beam with a little bit overhang. Note down the four wheels of the locomotive produce vertical forces. The four wheels of the locomotive produces vertical force on the horizontal grider AB, on the horizontal grider AB. Determine the reactions RA and RB at the supports. Determine the reactions RA and RB at the supports. If the load P 9 kilonewtons and if the load P each 90 kilonewtons and Q is equal to 72 kilonewtons and Q is equal to 72 kilonewtons. We assume all dimensions are in meters. We avoid the mistake because we are following any unit system. Now let us see vertical because this is RA and RB, there is no horizontal reaction. It is a hinge joint, vertical and horizontal, and only vertical, because it is a plane, 3 degree of freedom, 3 unknowns can be solved. It is statically determined. But RAY and RAX, there are no other forces, external forces are reactive or reactive forces. That's why that is neglected. Now let us see upward forces, RA plus RB plus 3P plus Q. That's what RA plus RB is equal to 3P plus Q. Okay, the P value, Q values are given here, 90, 72, 90, 72. We have got one equation. Then moment about A point 0. This force into perpendicular distance. Then this is a counterclockwise and these all are clockwise. That is how the moment can be determined about RA and about RB. Okay. So this is how the expression can be represented. Now let us see this one more problem. Now done, this is one little bit important as compared with the previous, because here one fixed pulley is also there. A beam AB as shown in figure. A beam AB as shown in figure is hinged at A point. Hinge means two reactions, RAX and RAY, and supported at B by a vertical cord which passes over a frictionless pulley at C, which passes over a frictionless pulley at C. Which passes over a frictionless pulley at C and carries at its ends a load P, load P. Determine the distance x from A, determine the distance x from A at which a load Q must be placed on the beam, at which a load Q must be placed on the beam. If it is to remain in equilibrium in a horizontal position, neglect the weight of the beam. The weight of the beam is negligible, we have not considered. Now draw the free body diagram of this separately and this separately. Okay. Let us say the Q acting downwards, RA, because there is no horizontal, only vertical RA, and S. If S is equal to, that is if once S is equal to P, that is they will give the length in terms of length. Okay. Now sigma MA is equal to 0. That is S. Whatever it may, we can assume some tension in this thing. S into L total is a counterclockwise movement, and Q into X. If from this find out X is equal to PLQ. If P and LQ are given. Okay. If reaction is upwards, if the reaction here downwards, if we can assume the other case. Okay. So this can be determined. Now let us see the similar problem. Because here, whatever the tension here, the same thing if you can cut it, because this is weightless, P is equal to S. That is S is equal to. Now down to the another problem. A prismatic bar AB of weight Q, is supported by two vertical wires, at the ends and carries at D a load and carries a load P is equal to 18.9 newtons as shown in the figure. Determine the forces SA and SB in the two wires. Let us see here acting loads are 2 PQ are given L by 4, L by 4, L by 2, the midpoint. If Q and P are the known weights, that is, these two are given. Now what we are doing, resolving vertically, this one, P plus Q is equal to SA plus SB, the two tension. This is the free body diagram. From this SA plus SB equal to one equation. The second equation is, because two unknowns, we need two equations. One is vertical force, downward forces, then moment about a particular point AG. Moment. So that means in this SB, or moment about B or moment about A, the choice is yours. Moment about A, SB into L and SD, SC. That is about point D. This force multiplied with this distance, this force multiplied with this distance. Okay. Now this is what SB into L, total L, is equal to P into L by 4 plus Q into L by 2. From that find out SB. This SB is substitute in this, we find out SC. Okay, this is how the free body diagram can be represented and determine the unknowns. Okay. So now let us go to the concept of third concept, which we have. See what we have covered till now. Method of moments, the parallel force. Because center of gravity concept also, we are using the same philosophy we are extending. Centroid or center of gravity. Center of gravity is a point through which the resultant of the distributed gravity forces passes, regardless of the orientation of the body net force. If you divide a particular continuum into a number of small cell elements, each weight is having, each particular cross section is having a force. Okay. Now what we have to do, it is that point through which the resultant of the distributed gravity force passes, regardless of the orientation of the object in a space. At that point, at this point through which resultant of force of gravity, weight, body acts. A centroid is an area lies in the axis of symmetry if you take this. Only area, like these shapes if you can consider. Area means two dimension. Center of gravity applied to bodies with mass and weight, centroid is applied to plane areas. That's what. That is another difference between center of gravity is applied to bodies and with mass. Now that is the concept where now it is derived also. Here the combinations in that particular case is, now let us consider what is this concept. Mass into weight and centroid is applied to plane areas. That is, let us consider the T section. This is 1, this is 2. A1 and A2, you find out. Rectangle, length into, but if dimensions are given, you can easily determine it. Now by using that with reference to base x, base y, you have to determine corresponding perpendicular distances x1, that is a1 x1 plus a2 x2 is equal to the total area a1 plus a2 into center. You can find out. If it is the integral, instead of summation of two rectangles, so but now I want to make number of elements. I have to make add on all those. In that case, you can use but to go for we have to find out the centroid by moment of area by total area. A1 plus A2 is the total area. XDA and YDA. It is a continuous system. If suppose a particular uniform cross section like 2, you can use a summation like this. It is an integral. So this is how the central gravity and centroid concepts are applicable and how it is derived. Now let us see the simple triangular shape. How to determine the centroid. Construct a triangle ABC of base B and height h. Determine the distance of centroid from the base. Here what we have to do is ABC is one triangle, AEF is one other triangle, both are similar triangles. Okay, by using similar triangle concept, B1 by B is equal to H, total H minus Y. H minus Y. When with reference to this point, when height H, length is B. When that's what here we can use. B1 by B, B base, two bases is equal to here. That can be determined. B1 is obtained. This one. This further simplify H divide both sides 1 minus Y by H. Then area of the element is this one is B1 into dy. Okay. Area into B1. Length is given. Area is known, length is known. Now go to the actual derivation. This YDA by A. YDA. DA is already, this is the area. Area is half base into height. D. Then what we have to do? You have to integrate the numerator, find out this one. This particular. Then simplify, finally get H by H. Or in other words, for a triangle, the centroid distance is H by in a particular from the base, the centroid for a triangle is H by H. Or consider a circle, semicircle, otherwise, or a full circle. The choice is yours. Here I am taking a small element because earlier rectangles here you can see rectangle we can consider with in terms of the discrete values. If it is a continuous, accordingly we have to see that this particular element, this is r theta and this is d theta, dr and r dr, d theta. Due to symmetry, centroid must lie on along the y-axis. With reference to this axis, it is symmetrical. With respect to this axis, it is not symmetrical. Okay. Now what we have to do is, we can find out the area of an element. This is r d theta length, width is dr. This is what dr into r d theta, area of an element. So this is from here to here by the bottom surface r, this is theta and this is d theta and this is dr, because it is a two dimension. So now what we have to do is x is equal to yda, because this is the symmetry. You have to find out the centroid of this x. X is yda integral. Area of the element dA, this is the area, r d theta dr. Then y component. If this is r, x component is r cos theta, y component is r sin theta. That we have to substitute. R signs. Now this is what is the expression. Then find out the value. And now integrate from the limits 0 to R, the maximum radius. We'll get this. This is what is called 4R by 3pi. From here, we'll get 4R by 3. Okay. See, like that we can get the centroid distance, centroid gravity dependent upon the 2-dimensional and 3-dimensional. Now let us, these are the some of the components. We have seen triangle, we have seen semicircle and other shapes. Simply given how to represent the centroids. For a rectangle, you can see there. That is half of the, this is the centroidal distance, x and y. This is b by 2 and this is d by 2. Area is BD. This is triangle half base into height area. Then x is, this is x and this is y. With reference to y it is symmetric, with reference to x it is unsymmetrical. Now that we already seen, find out the centroid of a given system. Half base into height, x component and y component. Y component is h by 3 and x component is, because this is x, y is this, h by 3 and x is 0. Now semicircle, x is 0, y is by symmetry 4R by 3pi. Just now we derived. Quarter circle, this is 4R by 3pi already. And find out the remaining values, x with respect to x. Now let us consider, find the centroid T section, which we already done previously, but once again with the numerical values now. With respect to y-axis, if I take like this y-axis, if I take like this, with respect to y-axis, it is symmetric. Okay, so that's why AY by summation of what the two rectangles are given, summation of two rectangles in the numerator, the area into distance divided by the total area. Okay. A1 y1 plus A2 y2. A1 y1 plus A2 y2 is equal to total area. A1 plus. They all are given. This is what is x and y. X and y distances. You find out. From the origin we have counted otherwise. X distance. Y is 50, with reference to this, it is 100 plus 10, 1 time. Okay, this as a base. Now areas are known to you, 100 into 20 rectangle, another area is 100 into 20, 200, 200 into, these are the points. So this is how generally we determine the centroid of T section. Because it is a two-dimensional, we'll call as centroid. If it is a three-dimensional, we'll call as center of gravity. Okay. Now let us consider, earlier it is a, but it is also a symmetrical cross biceps. Now let us see. This is area A1, A2, A3, G1, G2, G3 is given in the same manner. A1, A2, A3. Now what we have to do? Area A1, area A2, area A1, A2, A3, find out three areas. Because with reference to x-axis, 0 only with reference to y-axis, there are the distances. See the y, the first y is 30 by 2, 15. Second y is 30 plus half of this 100 by 2, 50, 50 plus 30, 80. Third is 30 plus 100, 130 divide 10 and 40. Now this is how we have to determine, because three areas are there, A1 by 1, A2 by 2, A3 by 3. You substitute all the data. So that is how we will use the expression. Now see here, composite figures. This is the triangle, this is the quarter circle, this is the square 4 into x, it is 8x, it is 6x, it is also 4x. 4x, 6x, 4x, 4x, 8x. Total, this is a 4x in terms of all the edges are given. Take the x is equal to 48. Okay. A1 is area of the triangle, A2 is the area of rectangle. Area of rectangle and area of subtracted rectangle is this one. Based on given data, this is what is the geometry is given. Then you can easily find out by same logic. Now let us see here. Divide. Area of semicircle to be subtracted, area of quarter circle to be subtracted, and area of triangle to be added. If I can take this as 1, semicircle to be subtracted, 2 square and semicircle, quarter circle and semicircle. These to be subtracted and this to be added. See, that's why length into width, 12x into 14x, it is a rectangle. In that you subtract 3. Area. See, this is what now the expression is. A1, A2, A3, A4, A5. A3 is area to be subtracted, pi r square, area of quarter circle subtracted, and area of triangle to be added. A1 is area of rectangle, 12 into 14x. This is 12 and this is 14. Both x are there, is x square. A2 is the area of triangle to be subtracted. Now find out here A1, A2, A3. Now let us see the about x-axis, these are the distances, about y-axis, these are the distances. For a triangle, it is a h by 3, 4r by 3 pi. This is the midpoint. See, like that you have to find out the distances. 4r by 3 pi, y coordinate 6x, 10x, x coordinate. You find out and find out the total. Now let us see the A1. A1 is area of rectangle. X coordinate is out of 14x, 7x. Y coordinate 12x, it is 6x. 7x, 6x. Okay. For the total area. Now area of rectangle to be subtracted. This is a rectangle. The x coordinate is 2x. Y coordinate is 8x plus 2x. 8x plus 2x. Now this is what 2x, 10x. 2x midpoint, 10x, 8 plus 2x. Similarly, A3 is already determined. A3 is this area of semicircle is pi r square. Now A3 is This is A3. 4r by 3 pi, that is x coordinate, and this one, this y coordinate, and x coordinate is this length 2x plus midpoint. Midpoint is, we can represent this length r by 2. Wherever is r, we can substitute. This is what, 4r by 3 pi, and here it is 6x. Two x plus 4x, 6x, 8x midpoint. This is what? A4 is the area of quarter circle to be subtracted. Okay. This one. Here 10x plus this. Or you calculate the center of gravity from here. You can start like that and solve. This is what 10x and 8x. 4 plus 4, 8x. And it is 10x plus this distance. Here. This is what 10x plus 4x. Sorry. This is the 4x from the base 4r by 3 pi. See, that's why 4x minus 4r by 3 pi. Here also 4x, 8x plus 4x minus 4r by 3 pi. That's what here expression. Okay. Then the A5 is area of triangle. This is the triangle. Half base into height. H by 14x. From here to here it is 14x plus the base h by 3. Similarly here. We substitute all the data, we can find out xc and yc. See, this is how the composite sections centroid can be determined as per the geometry. To determine the composite section, you have to concentrate individually, like triangular section separately, semicircle separately, circle separately, quarter circle separately, rectangle separately. Then find out what is the total xc and yc. Now let us see try this. In the meantime, we have determined the centroid. In this, let us see. This is the triangle. This is the semicircle and full circle. 3 sections. You have to subtract full circle and add these 2. Let us try. Areas are given. See, area of triangle, area of semicircle. Other 2 semicircles, because from the triangle 1 semicircle, from the semicircle you have to subtract another semicircle. Once you find out one semicircle is small, that same thing can be subtracted in both the cases. The area of triangle is half base into height 80 into 80. Area of semicircle is full semicircle minus this. Okay. Full semicircle diameter is 80 and small semicircle diameter here to 40. You find out the area of semicircle like pi r square. Here r is equal to d by 2. Pi r square by 2. Pi r1. R1 is d by 2. That d by 4. Already 2 is there. Pi d square by 8. This now will find out A1, A2 and A3. And then you find out the centroid. Along x-axis is the midpoint 40. Along y-axis it is 4r by 3 pi. This is r. This is h by 3 and this is h by 3. From the apex to h by 3. Total h. If it is h by 3, it is 2h by 3. Total h. If it is h by 3, 2h by 3. From the base, 4r by 3 pi, 4r by 3 pi. From this axis, it is a midpoint. See, like that you can find out. The areas are already given, 3 areas. That is the first column. X is due to this area. This area 40 means it is a 20. Total 40. That means 20 plus out of this, because with reference to this point 40 already given. Okay. 40, 40. And whereas this 3200 is this area of triangle. This one. From here apex to h by 3. 2h by 3. Okay, those are the x of 3. Then go to the y. Because with reference to this is h by 3. 80 by 3. And from this 4r by 3 pi. For this r is 40. For this r is 20. H by 3, 4r by 3 pi. Because we have to subtract. For this h 4r by 3 pi, for this it is a same, along the same it is a 0, the third area. Now x coordinate, y coordinates are given. Area into x1, area into y1 is this ax1, ay1. Now summation of all this, okay, because there are 3 areas. In this semicircle to be subtracted. Full circle otherwise. This one. Now 3 areas you can see and find out the expression. Now let us see the one more last one related to composite sections. In this square and in the square you have to subtract. Not square, it is a rectangle, because it is a 200, it is 150. It is a rectangle. In that you subtract triangle, subtract this one also. Circle. See, A1 is rectangle, 150 into 200, 30,000. Area of triangle, half base into height. This is 100 and this is 75. Okay, you find out 175 centroid. Now this is half base into height. Base is 75, height is 100. Then the triangle 100 plus h by 3. 100 plus 100 plus this is 100 only, not 200. This is 100 by 3 because with reference to this we are measuring. Then y is 75 plus h by 3. 2h by 3 it is. 2h from the apex. So 200 into 2, 200. Not this 200 means 2h by 3. This 150 means 75 by 3 into 2. 150 by 3. This is now this particular circle is a midpoint, 75. See, once we know a1x1 plus a2x2 plus a3x3, a1y1 plus a2y2 plus a3y3, a1 plus a2a. This is what is the Varnya's theorem. We can find out what is the centroid. You sum up all this to be summed up and this to be subtracted. Add all by putting plus sign, minus sign, minus. Similarly, y also. Okay. So this is how we have to determine. These problems you can try at home for other types of composite sections. You can treat as an assignment. You can do without practice. You will do a lot of mistakes. Please do practice. But here, if you can see, the combinations are quarter circle is there in this triangle and one ABCD section. Here 3 rectangles. Here one semicircle and one quarter circle. This is the Tim-Sheng problem. Uniparabola and triangle. Okay. We can find out like this any cross sections. Now let us see once we completed the centroid, center of gravity. Now moment of inertia. How to determine for a plane figures. This is the topic which we are going to cover today. This is the area moment of inertia. We are using in statics, not dynamics. Dynamics we are using mass moment of inertia. Mass of the body we will consider in dynamics. Okay, here in statics only the gravity head we consider if we resolve the problem. Sometimes mostly we will neglect. The moment of inertia plane figure, let us say any figure, laminar of area dA, and this is the x coordinate and this is the y coordinate and this is the r distance about point O. It is defined as square of distance, that is ix, about ix square of distance, y square into dA, about a yy square of distance, x square into dA. See that moment of to differentiate will consider ixx, iyy like that. Ixx, iy are the moment of inertia about axis. Similarly, polar moment about IO, r into r square into d. See like that we can represent the definition. This is the definition of moment of inertia. We can use the unit of moment of inertia is expressed as, because distance square, x square into dA. dA is also square, this is also a square. That is power 4. You will get the unit of power 4. Now let us consider different laminas. Like this. Frequently what we can come across like triangle, square, rectangle. This is a rectangle. We'll get square or a triangle or a circle. Then you can see the composite section. How this can be applied in composite section also. Here the moment of inertia plane figure rectangle case, consider rectangle of small width of dy. About x-axis, y-axis passing to the centroid. The distance are given. This is B and this is D. Let us consider the small now let us consider here considering the elementary strip width dy width and b is the depth. Area of the strip is b into dy. Area of the strip is b dy. This is what dA is equal to b dy. B dy means this is width and this is depth. Depth is small element. Now I want to integrate along this axis from here minus d by 2 to plus d by 2, like that we have to find it, or 0, depend upon what moment you want. Now let us see here into y square b dy. Now minus d by 2 to plus d by 2 from the about the mid centroid axis, front axis, you have to integrate y square b dy. B is a constant, take outside, y is a variable, y cube by 3 integral, substitute d by 2, d by 2, d by 2, d by 2. Similarly, if we simplify this, bd cube by 12, ixx. The same way you can obtain iyy, that is x square dA. Iyy is equal to x square dA and ixx is equal to y square dA. About ix, y distance, about x, about y, x distance we have to consider, about x, y distance to be considered. Area of the strip is same for both the cases. So this is how we will consider the moment of inertia about the x-axis and moment of inertia about the y-axis. Now let us consider triangle. Moment of inertia of a triangle. Here also let us consider a small strip. It is b1 into dy. Let us make it approximate rectangle, approximate. b1 into dy. What is b1 is similar triangle. This is one triangle and this is another triangle. Okay. If it is h, this is h minus 5. The base is known and height is known. Half base into height. You find out the area. Base is this into h minus y by similar triangle technique into b. From this point, for h height, for h length, b is the base. For h minus y, what is the value? That is what is b1 into h minus y by hp. That is what is b1. You can determine. Area is, this area is b1 into dy. That is where we have to substitute here. Okay. Then y square into dA. Y square into dA you can substitute and integrate. Moment of inertia of the about AB is equal to y square dA. Integral 0 to h. The limits. From this you find out bx cube by 12. Similarly, to simplify, simple integration. Similarly, IAB can be, that is a triangle about the base is ph cube by 12. Same as what we have done in the db cube by 12, it is bh cube. For a triangle about base. But other points it will change. About other We want to calculate the moment of inertia. Now let us consider simple laminas. These are in a composite section we are getting all this. Already mentioned we will consider mostly 2D cases. Here 2D lamina we have considered. Only we find out the centroid. Once we know the centroid, we can determine the moment of inertia. Moment of inertia of a circle about its centroidal axis. Consider the strip, small strip, this one, R, dr, this is d theta, r d theta, r d theta into dr. That is what is the area of element. Then y component is along this is x-axis, y component is, this is r cos theta x component, r sin theta vertical component. This is what is y. R sin theta square dA is r d theta dr. Now you can do the d theta dr, two limits. Theta is 0 to 60 degrees and r is 0 to r. You have to integrate 0 to 2 pi, radians 0 to r. You got theta d theta dr. The integration you have to find out. This is the value. So this is how the moment of inertia of basic laminas like a circle or a triangle or a rectangle, etc. can be represented. Okay. Now some more theories like, now let us see this is further simplifying. Only now the integration 1 minus cos 2 theta, 1 minus cos 2 theta. In first we do the one integration. Theta is, these are the boundary condition. R is, this is the boundary condition. Theta is this 1 by 2. Integration is, you know very well, it is 1 by 2 kept outside. This is theta minus sin 2 theta by 2. Okay, substitute boundary condition 0 to 2 pi. 0 to 2 pi. Theta, if it is 2 pi, only bracket term. Theta is equal to 2 pi. And find out the Ixx, Ix. Now these are the some more principle. The moment of inertia about an axis perpendicular to the plane of lamina. That is what is the z axis. J is equal to r square dA. These are the three. This is already explained earlier, but now this is the moment of inertia of an axis perpendicular to the plane of lamina. Plane of lamina is along x and y. Perpendicular to the lamina is r distance. That is square root of x square plus y square. R is equal to square root of x square plus y square sigma square sigma times r square d. Now one more parameter is defined, radius of gyration. Instead of distributed, if you keep similar mass or weight or area at a particular point, concentrated. Let us take 1 kg weight, 1 kg cotton. Cotton is distributed. If you keep 1 kg weight at a particular place, by using that, the radius of gyration is derived. Okay. Now radius of gyration is nothing but in such a way that if this area is concentrated area like this, then the distance times like squaring both sides, then I is equal to AK square. In such a way that if this is a concentrated, multiply with some distance square, we will get the expression like this. That is what is the mean. Where K, that parameter K is called the radius of gyration. I is a moment of inertia, A is a cross-sectional area, so that we can have the following relations. Kxx is equal to Ixxa, Ixy, 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 IYYA and IZZ. Like that we can find IRR AB with reference to AB. Now the two more theorems, perpendicular axis theorem and parallel axis theorem. These two also we are using frequently in our subject, perpendicular axis theorem and parallel axis theorem. These two theorems are very, very important because if the moment of inertia about one axis is given, if I want to determine the moment of inertia about the other axis, we have to apply the parallel axis theorem. If two moment of inertias are given x and y, you can no need of calculation of IZ, perpendicular moment of inertia, is called this is what. Now let us consider perpendicular axis theorem. The moment of inertia of area about axis perpendicular to the plane at any point O is equal to the sum of the moment of inertia about two mutually perpendicular. That is IZZ is equal to IXXX and IYY. ZZ can be represented R square here. R square is equal to square root of x square plus y square as per Pythagoras theorem. R square is equal to square root of x square plus y square. Then that you can sum up, find out integral, that is the summation. Sum is x square ds, sum is sigma y square ds. See, this is how the perpendicular axis theorem can be determined. No need of again derivation, only once we know the Ix, Xx, Iy, we can use the perpendicular axis theorem. Now let us see the parallel axis theorem. In parallel axis theorem, if moment of inertia about center of gravity IgG is given, this one, IgG, then the moment of inertia about this point is equal to moment of inertia passing through this point, area into perpendicular distance square. This is the parallel axis theorem. The advantage of this theorem is, once we know the moment of inertia about one axis, the moment of inertia about other axis can be written by using this. This is very, very important when you want to consider center of gravity of the particular system. Okay, these are the two principles generally will apply: perpendicular axis theorem and parallel axis theorem. Now let us consider for different sections. We have considered centroids, center of gravities, etc. Now, by using that, we will find out composite sections also we have done. Now let us see how to determine the moment of inertia for a rectangle about centroidal axis. This is xx, yy, b and d. Depth, that is the dimension is given. Moment of similar inertia about a xx axis, yy are given, derived. Similarly, let us take a rectangle and give a solution. In order to do that, what we have to do is, Ix is equal to breadth into depth cube, center of the Iyy is equal to depth into breadth cube. Let us say these two are known quantities, which we already shown previously. This is what's rectangle, BD cube by 12 and DB cube by 12. About XXX, about YY. Where a triangle BH cube by 12. These you have to remember. For a square pi d by 4 by 64. Always unit is meter power 4. Okay. Now let us start with Ixx, Iyy known to you, BD cube by 12, BDB, DB. When Ixx breadth times depth cube, Iyy breadth times depth cube. That is what is the meaning. Okay. Now I want to calculate the moment of inertia passing through this point, this axis. This we know. That's why IAB is equal to moment of inertia passing through the center at IXX plus area of this into H. Okay. That's what he bottom and simplified. It is coming as BD cube by 3. How simple form it can be. Similarly, you can obtain other sums. You put a hollow rectangle. Here B and D are different. Then see inside you have to subtract. That's why it's already we have derived BD cube by 12. That period for a bigger triangle and a bigger square and smaller square. That's a BD cube by 12 minus BD cube by 12. That is what is the moment of inertia about the axis. So this is how generally we determine the hollow sections. Now let us see the moment of inertia about triangle. IAB is equal to IG is known to you. Just now we have derived moment of inertia about the this is the triangle. This is the triangle about the BH cube by 12. Similarly, if we can use here IA is BD cube by 12, already we got, plus area into depth by 2 whole square. From this you find out A square. And you add this moment of inertia passing through centroid. See, like that the transformation, once we know the moment of inertia about one axis, the other axis can be determined. Suppose if this is given, I want to determine this is the expression. If this is given, I want to determine this AH square you put minus AH square. Like that the transformation can be done from one point to the other point. Okay. This we already seen. Now let us start with the triangle. BH cube by 12, BH cube by 18. 18 how we got is the area into length square. Length power square. This one. Now you can see this is already known to you. This you can determine from this IXX. Vice versa can be done. IAB if is given, IXX can be calculated. If IXX is given as passing to the centroid, IAB can be calculated. Let us see the semicircle. Moment of inertia pi d power 4 by 64. Okay. Here the same derivation we can start. Then we can find out the pi d power 4 by 128 because this is the about this is known to you and find out this one. Okay, centroidally the distance is h 4r by 3 pi. R you can use 2r is equal to d diameter 2d by 3. Okay, area is pi d power 4 by this is the area and this is the length and this is the moment of inertia passing through this point. Then IAB is equal to IXX plus CH square. IAB is known to you, area known to you, H square known to you, then IXX. IXX can be find out. That's why vice versa condition. If IAB is given, IXX can be determined. If IXX is given, IAB can be determined. Okay, this is how we can do. Simplify, then find out the IXX. Now let us start with the composite section. This is the last part of our today presentation. Centroid we have considered laminas separately, triangle, rectangle, square, semicircle, circle, etc. Similarly, moment of inertia also we consider the laminas. Now let us see the composite section. Earlier of centroid we consider the composite section, then how to determine the moment of inertia of composite section about axis passing through the centroidal axis. Here the solution is, this is A1 and this is A1 and A2. A1 is length into width, 10 into 150. 10 into 1. A2 is 140 into 10, 1400, 1500. Then the centroid Y is A1 Y1 plus A2 Y2 divided by total areas, A1 plus A2. This is the centroid, A1 Y1. Y1 is this 140 plus half of this 5. A1 Y1, A2 Y2. Y2 is half of this 70. By A1 plus A2. So this is how the Y can be determined. Once we know the Y, because with respect to this axis it is a symmetry. Then the moment of inertia about the x-axis, about x-axis is equal to 112 BD cube of about y and parallax theorem about this passing the moment of inertia about this axis, that is 1000 BD cube plus a into depth square. What a this area. See, 112 BD cube area of this concern area, 150 into 10 into x square. Plus second area, A2 plus 112 BD cube plus A2 is 140 in 10, 1400. The centroid distance of this minus you can 14 into x square. Okay, 1000 BD cube. This is 140 plus 5, and here out of 140 is 70. You can use this is 70. The total here we already determined previously that if you can substitute, you can find out the value. Area into x square. Okay. So this is how we can find out the value of H is the centroidal distance of the common centroid. Find out that we already got. This is H. This is H minus y. This is also H minus y. Okay. Because H is somewhere here with respect to this is a perpendicular distance, area in two axes. So that's why 145 minus of this you have to subtract. When you are coming only this area, this is below than this. That's why we are getting a negative. Okay, find out the moment of inertia of the total lamina and determine how it is represented. It is also almost same. Determine the moment of inertia of composition about an axis passes through the centroidal axis. Also determine the moment of inertia about an axis of symmetry and radius of symmetric axis. That means about Ixx you are in, now about Iyy also you have to find out. See, that is what we have given here. Okay. But this is to be very carefully done, otherwise there are a lot of mistakes. See, Iyy, then radius of gyration. Once you know the Ixx, Iyy, moment of inertia is also represented as for concentrated cases. Distributed is I is equal to A into that x square or a into y square like that. Radius of gyration is concentrated area. See, that's why k is equal to I by a. Once we know the ixx, area is known to you, find out radius of gyration, the square root of a. But only difference is this is used for concentrated masses, the other expression a, ax square or ay square, that we can use for r square dA, use it for distributed. Okay. Similarly, yy, we can determine. See, this is what is the radius of gyration. Then let us consider the L shape. Determine the moment of inertia of the section about its centroidal axis parallel to the. Also find the polar moment of inertia. That is IZZ. That is nothing but Ixx plus Iyy. See, this is what A total centroid find out first. A1 y1 plus A2 y2. A1 is 10 into 125. This is what A2 is 75 into 85. This is 75. Please, 75 into 10. Then total area is 2000. A1 y1 plus A2 y2 divided by A1 plus A2. A1 is this 125 and this one is 10. The total distance, because base from base is there, no need of adding 10. Out of this half 62.5. A1 y1, whereas this case 5. 750 into 5 by A1 plus A2. This is the centroid. Distance from the centroid axis yy about 2. This one xx. Now x bar is A1 x1, A2 x2 plus A3 x3 about this axis. Okay. Here also again 5 A1 x1 125 120 125 in 10 area into x1 is out of 10 5 plus from the base 85 off. This is 750 area into x2. If it is 10, 10 plus 75. 75 means 75 by 2. That's what 10 plus 75. Total area. See, these are the centroidal distances. Once we know the centroidal distance, Ixx is equal to 1/12 BDQ. 1/12 BDQ plus area into distance between the two axes, square of the distance between the two axes. See, about first area, Ax square. 1250 difference of this centroid and this centroid. This centroid is 5 and this centroid is, see, that's why this is x. (62.5), 62.5, but actually y is this much. That's why the x is the difference of the two x. Similarly, 1/12 BDQ of second and the distance between this axis and this axis. That's what can be determined. Find out the total moment of inertia Ixx and Iyy. Similarly, determine Iyy. Once we know the Ixx, Iyy, find out Izz. That is the perpendicular axis theorem. By adding simply the two moment of inertias, we can determine the total mm per 4. See, now let us consider determine the symmetrical I section. What is the Ixx, Iyy also determine the polar moment of inertia. Here three areas three rectangles. One rectangle is 200 into 9, 1800. Second rectangle is this one. The length is 250 and this length is 9. 9 and 9, if you can subtract 18, 232. This is 232 into 6.7. A3 is 200 into 9. The top web and bottom web is same. It is looking different. A3 is 200. This is 200 into 9. Now A1, Y1, A2, Y2, A3, Y3. A1, Y1. You can see here. A1, Y1. This is with respect to Y, this is 200. That means 100. A2, Y2. A3, Y3. This is A3, Y3. Y3 is this. This is 6. Distance half of this. A1, Y1 plus A2, Y2 plus A3, Y3 divided by A1 plus A2 plus A3. Then IXX, 1/12 BD cube. This is what we got. Centroid is 98.98. Similarly, find out IYY, 1/12 BD cube of 3 areas. Then corresponding areas into difference of distance between the two axes. Okay, find out, and similarly about IYY, and find out the polar moment of inertia. So this is how generally we can determine. Now the same, this we have done for the moment of inertia. Here simple logic, square, triangle, semicircle, two sizes. About this point, semicircle moment of inertia are triangle 1/12 BD cube, semicircle and circle, pi d power 4, 60 power 4, and pi d power 4. This is 100, this is 50, and this is 50 means 25. Okay, pi d power 4 by 64 minus, you have to subtract. Here also, if you want, you can substitute d. It is also 100. Now, three moment of inertia, because all are symmetry with reference to this axis of x and y considered. So now, this is what the today class. Today we mainly concentrated on the 4 aspects, that is method of joints, parallel forces, centroid, center of gravity, and the extension of and moment of inertia of laminas, 2D problems. These all we have considered. In that, we have considered simple sections like triangle, rectangle, and circle, and composite sections also. Similarly, not only centroid, for composite, simple laminas and composite lamina, we have considered the moment of inertia centroid also. So these are the things which are very, very useful when we are solving the static problems. Okay. Tomorrow we will see some of the issues like there is the last class. We will see the moment of inertia, mass moment of inertia, center of mass, and some more concepts which are left in plane motion, like instantaneous center, relative velocity methods, kinematic as well as little bit kinetics we already discussed. Kinematic, these are some methods. Kinematic like relative velocity method, instantaneous center method, etc. With that, almost all the syllabus of both the mechanical as well as the civil engineering students is covered. My dear students, please try more number of problems because this is the subject where once you clear with the concept, the problem to be solved, the practice is very, very important. Otherwise, we cannot cope up. And concept should be clear. Once we know the concepts clear, and any problem can be solved. And method of moments and parallel forces, we have to draw a free body diagram, then analyze the system. Where moment of inertia, you take a cross section, what are the type of cross sections are given. Calculate moment of inertia, mass moment of inertia, area moment of inertia, and find out these application of these moment of inertia and centroid in the later stage. See, with this, thank you very much for your patience hearing. Even Grahan also, you have attended the class. I am thanking for your presence today and best of luck for the entire day. If you have any questions, please send in through Google Forms and we will give a reply. Not only today class, the last 10 classes, what we have done, accordingly you can give your feedback and send the feedback also. It will be improved in the later stage because JNT Anantapur, Kakinada and Yogamana University as well as Ambedkar University, this is the third cycle they are organizing. In the next cycle, what are the hiccups and if any problems which you are facing or anything regarding content, regarding delivery or regarding speed, any concepts you can give a feedback, it is very useful. Thank you very much for your patience hearing. Best of luck. With this, we will close the class.